Okay. Everybody say hi to Kylie because she's the only one that's not live right now. So apparently she's going to go down and take on the Shenandoah Phillies, right? What's Van Meter's name? I don't even know. What are they? Bulldogs? How about no one cares, right? So the team that's supposed to win, do they always win? I don't want to hear this crap. Oh, Van Meter's so good. Yeah, well, too bad. They'll take care of business. It's your homecoming, not theirs, right? Van Meter. I didn't even know that was a town growing up. There's so much. Kemper Pride is. All right. So anyway, you said Bulldogs? I did not know that. All right. Are they blue or something? Blue and white? They're going to be black and blue after Friday night. So I can say all this stuff because we haven't prayed yet. But I'm tired of messing around. It's the real deal now. It's time to finish. It's not starting, it's finishing, right? All right. So anyway, good and bad things are going to happen. Just take advantage of them when they do. All right. We better pray. Who do you want to pray to today? These guys are like so excited I'm back. They're just staring at me. I really feel welcome. Who do you want to pray to? It's all right. Anybody? We'll do our Father? Father, Son, Holy Spirit, amen. Our Father, who art in heaven, hallowed be thy name. Thy kingdom come, thy will be done on earth as it is in heaven. Give us this day our daily bread, and forgive us our trespasses, as we forgive those who trespass us. And lead us not into temptation, but deliver us from evil. Amen. Mary, Queen of Victory! All right. So tomorrow I'll try, I think I can be available. You got a chopped up day, right? But Thursday's normal, so we got that half test. Everybody is going to be here. I'm giving that in class. All you can use is a scientific calculator. You really don't even need that. You just need a pen or a pencil. I am going to just real quick, because I guarantee you one's on there. Let's do the one that was in your homework, section 1.5. Section 1.5, the epsilon delta proof. Let's see, I'm going to get Mike, you can kind of look along if you want. The first few keys are pretty sloppy to look at my work, so don't worry about that. I wasn't really planning on ever handing those out, but I'm too lazy to rewrite them. It gets better starting about section 1.4, but I will share how I do stuff. Anyway, we wanted to prove using the epsilon delta definition or formal definition that the limit as x approaches 1 of 4x plus 3 exists and equals 7. Now, 4x plus 3 exists and equals 7. We can do this with the theorems very easily, right? Because that's a polynomial. And I said if it's a polynomial, you could just plug in, right? So for the limit theorems, limit of the sum is the sum of the limit of a constant times a function is the constant times the limit of the function, etc. We can just plug in. But I said if it's a polynomial, we can plug in. However, we want to do epsilon delta here. We want to prove this. So on the proof, the first thing we need to do is we need to verify that our function, which is right here, 4x plus 3, this is f of x, right? This is a, and this is our limit L, right? So we have all that. But anyway, we need to show that f is defined on some open interval containing a, x equals 1, except possibly x equals 1 itself. Well, the domain is all real numbers, and that is an open interval because it goes from minus infinity to positive infinity, and x equals 1 is in there. So I am defined on some open interval. So you have to show that. I will tell you right now, if you do not show that it's defined on an open interval containing a except possibly a itself, you're going to miss a point. So don't do that, right? So anyway, now what we need to do is we need to do some scratch work, right? So we need some scratch work. We need to do a little work to figure out what's going on. So we're going to let epsilon greater than 0. And we're going to, hey, Jordan, thanks for playing. Appreciate that. It says you just got on. That's all right. Do you have a computer? You don't have a computer. Huh? Well, you can see what I'm doing. Do you want me to just sit there and then you can look over my shoulder? All right. All right, so we're going to set delta. This would be easier than me trying to write on the board and be close enough with my camera. So let epsilon be greater than 0. Whoops, we don't know what delta is. We need to find delta. This is the scratch work. So we need to find delta greater than 0 such that what happens? 0 is less than the absolute value of x minus a, which is 1, is less than delta, would imply or guarantee that the absolute value of f of x, which is 4x plus 3, minus L, which is 7, is less than that epsilon. So really what I do is I'm going to focus on the right half of that, but I'm going to simplify over here and do some scratch work to figure that out. So let me go ahead and do that. I'll keep my scratch work going. I'll do that in red. So anyway, so I had absolute value of 4x plus 3 minus 7, which is 4x minus 4 now, is going to be, so that implies that's less than epsilon, which then I can factor out a 4, right? I'm left with x minus 1 is less than epsilon. And the absolute value of a times b is the absolute value of a times the absolute value of b. And instead of writing the absolute value of 4, I'm just going to write 4 because that's a duh thing. I will give you credit for certain things. This is less than epsilon, and then of course, you know, both sides, I got epsilon over 4. So I've got the absolute value of x minus 1 is less than epsilon over 4. So we're going to set that equal to delta. So this is our scratch work. This is the work that we are doing to solve this. And then what I do is on the formal proof, so I need to show this, and this is what most of you showed on your work, and then you just didn't go and actually do the proof. So what we need to do now is we need to go ahead and do the problem. So now we're going to say proof. So now we actually have the proof. We already showed the domain contains x equals 1, some open interval around that. Anyway, but now it's let set, right? So how many people put let set on your personal paper? Not very many. Let epsilon be greater than 0 and set delta equal to epsilon over 4 that we found. By the way, that's going to be the biggest delta window that we're able to use. Anything smaller than that would also work, but it'd be very hard to show. So then we're going to say 0 is less than the absolute value of x minus 1 is less than delta, implies, I'm just going to look at the right half of this. So it's going to imply that the absolute value of x minus 1 is less than epsilon over 4. So I'm replacing delta with epsilon over 4 right here. And then I'm working backwards. So basically I take my scratch work and I'm doing backwards scratch work here, right? So anyway, I'm going to get that 4 to the other side. So that implies 4 times the absolute value of x minus 1 is less than epsilon, which implies the absolute value of 4x minus 4 times the quantity x minus 1 inside of the absolute value is less than epsilon. I'm going to come up here, which implies the absolute value of 4x minus 4 is less than epsilon. So all I'm doing is I'm undoing all the scratch work in reverse order. And this implies the absolute value of 4x plus 3 and then minus 7 is less than epsilon. And that's what we needed. Therefore, 3 dots means therefore. So therefore, the limit as x approaches 1 of 4x plus 3 does exist and equals 7. And then we're done. So this is the nice proof. So essentially nobody did this. There might have been a couple, so I'm not picking on everybody. But most of the class is not showing this part. You're doing the scratch work to come up with delta, and then you need to show this. Okay? If you want full credit, show that it's defined on an open interval around x equals a, and then use your scratch work, and then use that backwards to prove this. All right? In general, The formal definition is let F be defined on I or I minus A. This is in my notes. Then the limit as x approaches A, if f of x exists and equals L, if and only if for all epsilons greater than 0, there exists delta greater than 0, such that everything else that I just showed. Okay? Any other questions on anything in 1.1 through 1.7? Continuity is not on your 50-point quiz. Okay, but we started it, right? What else you need? No other questions? Because I can go into that. Isaac's thinking. See, what's funny is you don't even know I'm looking at you, do you? I'm not on the screen, but you're on my screen. So, yeah, it's a nice day out, I know. So, get healthy. Hey, do you guys like ever? I mean, you go to church, right? You have to, like, as part of your training school, which is good, because now is an important time to embrace your faith. True or false? Like when they put you on quarantine, do you now have a new appreciation of the readings with the lepers? Like you feel like you're just excluded from society, and then you have this corner and go unclean, unclean. Yeah. And I'm not saying that to be a jerk. I'm just saying that I could see that you would feel that way. I had one of my good buddies that I play pickup football with, still to this day. But anyway, he like nobody would talk. This is early in the process. Like nobody would talk to him for months. So at least now I think it's better because we've been so immersed in it, right? And we know more. But like he was like, people wouldn't even call him on the phone because they thought they were going to get infected. Like, yeah, anyway. Ask your dad if that's possible, Isaac.
I don't think it is.
All right. So anyway, all right, moving on. Let's there's no other questions. Seriously, no other questions like half limits or stuff like that. Like looking at what I took points off on. Everybody can do better on your homework to turn in, and I will tell you this: previous classes think that 50-point quiz I give is one of the toughest things they've ever done, which is not true. But I mean, that's what they think. They're like, "Man, that was hard." Well, maybe your life's been a little too easy so far. I don't know what to tell you. So be ready. And I know it's homecoming week. All I can tell you is if anybody tries to TP me, I'll tackle them, take them out, and you guys will have much harder stuff the rest of the term. So you also have to protect me. Because if you don't, that's gonna be a bad deal, Jerry. Bad deal. All right. It doesn't matter. Like Carol, everybody knows everybody. Like, you know who's doing it. Like, I'm like, no way, man. Like, if you hear any inkling, no, just don't do it, man. Don't do it. When I was coaching, I ran down our fullback, Justin Klein, and he was like a stud, right? He was ripped. He squatted like 450, benched like, 380. And I ran him down. I caught him in my bare socks, and then I didn't know what to do with him. So I said, come back tomorrow and clean it up. And they did. But anyway, all right. So, just there are certain people that really don't like that whole TP thing. And I have called the cops and I have got permission to beat the crap out of somebody that's on my property if I feel threatened. And trust me, I will feel threatened anyway. But Justin Klein, I'd let him go. All right. Moving on. Nothing else? So do enjoy homecoming week, but don't forget you got to be a student as well. All right, student of the game. Do you guys you were just looking at a dry erase board the whole time, Isaac? I feel bad. Like, can't see my face in the corner? Okay. All right. Whoops. Oh, it's not even sharing. There now, it's sharing, right? All right. Well, I'm still here, but hey, MIZ!
ZOU.
Thank you. I knew one person would know that. All right. Thanks, John. All right. So, anyway, let's go. Nope, really no questions. You want to go back to continuity then? Learn some new stuff. There's not one question in 1-1 through 1-7. This day is supposed to be for you. I could look in Blackboard to see if I have keys in there. Let me just look. Student notes, homework keys. Actually, I do have keys in there that are unavailable. So what I'm going to have to do is I'm going to have to edit this. So here's what I want you to do. I want you to go into Blackboard, course content. And let's see. Can you now see homework problems to turn in? Homework keys. Can you see that? On chapter 1, go into Blackboard, chapter 1, course content, homework keys.
Can see it.
All right, so, and then all I really have to do then for Kylie, Isaac, and John is scan the ones that I graded back. I have not graded 1.7, which is fine. I can actually grade that on Thursday while you're taking the half test. Just, you've already sent it to me, so I know what work you did, right? That's what I'm gonna grade, and then you'll be able to see it on there, so. Okay, so we're all good on that. No other questions. I might as well do some new stuff. And then what's anybody know what Friday's day is like? Are we gonna have class?
I thought we have church, and then we have 1, 2, 3, 4, 6. So we're Thursday schedule, and then it's something
What period's this?
else.
So there's no 7? All right. Well, I'm okay. If you guys are okay, like meeting next week during when there is next week teacher conferences? You guys. Okay. Well, as long as there's not practices and stuff, like I would want to meet those days because those are scheduled days for us, right? So my schedule doesn't follow Kemper's schedule, but I also want to respect what you got to do. So anyway, so how about that? How about you just bust your hump? You be completely 100% ready for Thursday's half test, meet Friday. Tomorrow you can ask questions or that type of stuff too. We can use a session like this, I will tell you. So I teach other classes that are 100% online. And like yesterday, it was actually a former Kemper student was having questions with something. I said, hey, you want to do a Blackboard Collaborate? We can set this up as a one-on-one or as a small group setting anytime. I just got to set the time. So today was my fault. I think on the 2:15, I was obviously East Coast time because I've been on vacation or something.
Are we meeting in person tomorrow?
Huh?
Are we meeting in person tomorrow?
Tomorrow's Wednesday, so no. Tomorrow's a chop-up day, and then like normally it's a church day. So no, I'm not planning on meeting tomorrow. I want you to use tomorrow to get the rest of your Khan Academy done through the second quiz. Has anybody worked on it yet? And let's talk about Khan. Is it that hard or is it pretty easy? Is anybody done with everything that you have to do for the first for Thursday? How long have you spent on it? You did half, and how long did it take you? Half hour, an hour. I'm expecting you're going to have to spend 2 to 3 hours to do what's due Thursday total, but I don't know that. You'll have to communicate with me. No. You only have to do the ones that are exercises. If you want to watch the videos, it's just for you. Those are there for you.
So we
Go ahead.
do we go until squeeze theorem? Or
Yes, except that Yes, not including squeeze theorem, because I haven't covered that yet. And trig, you don't have to do the trig stuff. Here, let me share my screen.
Okay.
Can you see con? Yeah, so all right, sounds good. So yeah, this squeeze theorem and sine of x over x, limit as x approaches 0. We haven't had that stuff yet, so that's quiz 3. So what I did is anything after quiz 2 is not required. Double angle stuff and trig stuff I haven't used, but I have done like conjugates, rationalizing, factoring. So some of the stuff that is after, and I haven't reset the due dates on the stuff after that. I just want you to go through quiz 2 for sure, but then the limit, there is like 3 sections after that. Limits by factoring, limits by conjugates, and rationalizing. Those we have done that, and it will be on your quiz. So it'd be good to do those too. But you can stop at squeeze theorem. If it's trig stuff, we're not doing trig. We haven't even talked about trig. So you can skip that stuff too, unless it's on the quiz. It is on the quiz, isn't it? Anyway, I'm not concerned on I want you to get good scores, but like if you don't get every point right, I mean, it'd be nice to go back and get them if it's an easy fix, but I want you to do it, right? So I'm just going to give you credit for doing it as a learning tool supplement. The stuff that when I take my time going through your work, I'm going to be picky, as you can see on your homeworks. Nobody got 100% of the points, right? And most people had 1 or 2 that were like, man, if that was equivalent to whatever grading scale Kemper has, is not very good, right? I mean, y'all did good work, but I want great work. I want superior work on the stuff that you turn in. And I also want you to work together. Isaac, like it's okay to use WhatsApp and help each other out with that stuff, right? So make sure like, oh, I know, let's do the one with A and B. Let's do that one. Because like at best half the class got that one. I know that was a challenging one. That was, I don't even know where that is. What section was that? 1.6. Okay. All right. I'll go back to that. So instead of going to continuity, we probably have about time to do this. I can't get back into my course. Oh, I got to use my pen. Sorry. Ah. Anybody know how, did I get kicked off the internet or what? No. What can you see? Con? Why won't it? It's not changing my tabs. Like I can't do anything. Oh, stop sharing. Maybe if I stop. I think I'm locked up. It ain't working. Exit tablet. Yes. Okay. Fine. It won't go back. It won't go back. Stop sharing. Can I do that? This is really ticking me off. All right. You can't. Hey, there we go. It went back. But you can still see con. All right. See the whiteboard now? Man, I don't know what the heck the deal was there. All right, let's do that one. We had f of x equals 2x minus a with x is less than 3, negative 3, ax plus 2b, negative 3 is less than or equal to x is less than or equal to 3, and then b minus 5x if x is greater than 3. And so the reality is, if we want to find a and b, we want to find a and b where the limit as x approaches 3 and limit as x approaches negative 3 of f of x both exist. Okay, so if they exist, that means the left-handed and the right-handed limits need to be exist and be equal. So the left-handed limit, left, I was using green or blue. Let's use green here. So the left-handed limit, as I approach 3 from the left, I'm on this function, right? So the limit as x approaches negative 3 from the left, so put a little minus sign there, of f of x. Instead of f of x, we could just put in what it is. It's 2x minus a, right? Because that's where I am as I approach negative 3 from the left-hand side. So x would be less than negative 3, approaches it from the left. So now this is a polynomial because a is just some fixed number. So I can just plug negative 3 in for x, right? And so this ends up being minus 6 minus a. Does everybody agree? That is the left-handed limit at x equals negative 3. And you don't have to write this down because it's on my key. So you can just watch if you want. And then if I want to look at the right-handed limit at negative 3, that would be this function right here. I'll use red. So that'd be the limit as x approaches negative 3 from the right of f of x, but instead of f of x, it's going to be ax plus 2b. And once again, since it's a polynomial, I can just plug in negative 3 for x, right? And when I do that, it's going to be minus 3a plus 2b, correct? And what do you know about these two things? We know that these two things have to be equal if, because one's the left-handed limit and one's the right-handed limit. For the limit as x approaches negative 3 from both sides to exist, these have to be equal. So we set them equal to each other, and we'll get minus 6 minus a equals minus 3a plus 2b. And then basically get everything on one side is kind of how I do it. So let's say 0, so I'm going to add b to both sides, so that's plus 3b. If I add a to both sides, it's minus 2a. So minus 2a plus 3b equals 0, so that's what I get for that one. Now I can do the same thing on the other side. I'm going to use, try and use different colors here, I guess. If I come in from the left of 3, I'm still on this one. So the limit as x approaches 3, positive 3, from the left, I'm going to be on ax plus 2b, right? And if I plug that in, plug in 3 for x, I get 3a plus 2b. That is the left-handed limit at 3. And then I also need the right-handed limit at 3, which I'll use black. The right-handed limit at 3, I'm at this one. And if I plug in 3 here, I'm just going to go ahead and do this. The right-handed limit is going to end up being b minus 15, right? b minus 15. And then I know that these are equal as well. And so I've got 3a plus 2b equals b minus 15. Get everything to the left. I've got 3a, and then plus b equals 15, right? So I've got 2 equations and 2 unknowns. So there's a lot of different ways you can solve those. Uh-oh, what did I do on the first one? I did something wrong. Where's the minus 6? It equals minus 6? That was a mistake. That equals minus 6. Okay, correct. Anyway, and then what I got to do, I can solve one. Like if I want to solve the second equation for b, so b equals 15 minus 3a, right? You can always substitute into one and then plug it into the other. Plug that in for B. And then let me do that. I'm running out of room here. But anyway, sub that in there, and then I'll get just an equation in terms of A. Solve for A. You're going to end up with A equals -3 and B equals -6. Look at my notes to see that. A lot of you had -6 and 15. That's just a small typo or a small mistake like I did. I took off a point, but I could have maybe took off a half. Anyway, but that's how you do that one. And the bell rang, so see you later. If you got any individual questions, reach out to me and we'll go from there. All right, so I'll see you, you bet. I'll see you Thursday, guys, everybody.